Good evening and welcome. In today's video or tutorial, we are going to look at work inputs, work outputs, and efficiency. Now, these are our objectives for today. We are going to calculate work done, calculate work inputs and work outputs, calculate efficiency of a machine, and also solve some questions. Now, let's start. Now, work done is given by this formula, force times distance. Now, we say that work is said to be done when a force moves a body through a distance and in the direction of the force. So simply put, work done is equal to force times distance. Now the unit of work done is joules. Yes, so let's start with an example. When you are given a force, let's say we have a force of 250 newtons and a distance of 20 meters. Basically, distance is in meters. Now if you have to calculate the work done, since we know that the work done is force times distance, just multiply. So the work done, which is force, and force is 250 newtons times distance is 20. Now, since the unit of work done is joules, we add the unit to it. So we have 250 times 20. Now, when you multiply 25 by 2, you get 50. Then you add the two zeros to it. Yes, this is what I mean. When you have 25, you have 25 times 2. When you multiply 25 by 2, you're going to get to 50. So it's all 50. Yes. But since this is 250 and this is 20, you just add the two zeros to it. This zero and that zero. You just add them to it, so you get another zero, another zero. That's why I'm saying 250, 250 times 20 is 5,000. That is true. Now, there's the first example on the breakdown and be solved. Now, let's move to um, another example. So now, when you are giving work done to be 800 joules and a distance of 10 meters, now what do? You see, we know that work done, work done is equal to force times distance. That is yes, is given by distance, force times distance. Now, when you have to find force, given work done and distance, then what you are going to do is that you are going to divide through by distance. So here by d and here too by d. So that this one will cancel this. Now see our force is now going to be equal to our work done over our distance. Yes, so now we know our work to be what? Work done to be what? 800. So you put the 800 here. Yes, so we have our 800, then divided by, so these are 800, have the zeros well, divided by our 10, which is our distance. I know this zero cancel this zero, so leaving 80. So we have 80 newtons. So we know that force is measured in what? Newton. So this is the Newton, and this is the 80. We have 80 Newton. So that is how come we have force to be what? 80 Newton. So you see, our first question, we were given the force and we were given the distance, and we were asked to calculate work done. So we easily multiply. But if you are given the work done and given the distance, we can simply find the force by doing something of subject. That is how it is. Now let's proceed. We are done with work done, so we are going to work input. So work input is equal to our effort times effort distance. So keep this formula. Yes. So when you are inputting in a force, yes, you are going to put in some effort. Yes. Now you are going to put in an effort to move some kind of what load. through a particular distance. So the effort times the effort distance will give you our work input. Yes. And the work output will be our load times our load distance. Our load times our load distance. Now we knowing that our work input is effort times effort distance. We know effort is force. And the effort distance is measured in what meters because it is the distance moved. Then this one is a force. So this one is measured in newtons and this one is in meters. The same is true for work output. The load is a force, then the load distance, since it's measured is a distance, is measured in what? Meters. So now that we know the formula for work input and we know that of work output, let's take a question. Now, if you are given the effort 25 newtons and effort distance of 4 meters, then we can easily calculate what our work input. So we know our work input is what? Effort times effort distance. So since the effort is 25 and the effort distance is 4 meters, we just multiply. So 25 times 4 is going to give us 100 joules. And the same is also true, very simple. So work output, you know the formula to be our load times our load distance. So you just multiply them. So 20 times 2, then you have 40 joules. Please remember to bring the unit. Work done, work input, they are measured in joules. So you just add the unit. When you mark work anything signs, you don't add the appropriate unit to it, it will be considered as wrong or it will be considered as incorrect. So please make sure you add the appropriate unit to it. So work input joules, work output joules. The effort, since it's a force, newtons. The effort distance is in meters. Load is a force, 20 newtons. Load distance, 22 meters. So when you substitute the effort and the effort distance, you're going to get 100 joules for work input. So when you substitute the load and the load distance for work output, you're going to get 40 joules for work output. Now let's proceed. Now let's move to efficiency. Efficiency is defined by the work output um, is to the work input multiplied by 100%. So the ratio of work output to work input multiplied by 100% defines our efficiency. Yes. So if you look at this particular question, now since efficiency has to do with work output and work input, you realize that here we calculated our work input and we had 100 joules. Then we calculated our work output and we had 40 joules. So if you want to calculate our efficiency, it's just the work output over work input. So work output is what? 40. So we have our 40 divided by our 100 times 100. Yeah, so this is the calculation. So we have our efficiency here is equal to our work output. Let me use WO for work output over work input times 100% times 100% times 100%. Now I know our work output will be 40. So our 40 divided by our work input, which is 100 times our 100% times our 100%. Yes, times our 100%. And here we know that this 100 will cancel this 100. Yes, leaving this 40. This 40 will multiply the percentage sign. Then you're having this 40% as our answer. Having this 40% as our answer. So that is how we calculate efficiency. When you know your work output, know your work input, multiply by 100%, and you're good to go. You're good to go. All right. Now let's practice some questions. A force of 150 newtons moves an object 12 meters. Find the work done. So you can solve this one before we move to check the answer. Now, because we are asked to find work done, we are going to use the formula. You know, work done is what? Our work done, our work done is going to be our force times our distance. So our force times our distance. Our force times our distance. Now I know force will be what? 150 newtons. So 150 newtons times our distance, which is what? 12. It is advisable you take away the units, and after that, you knowing that work done is measured in joules. After that, add the units. So you multiply this 150 by 12, you are going to get the answer. Yes, you're going to get the answer. So when you multiply the two, we get the answer for our work done. So our 150 times our 12 is going to be 1,800. So we're going to have 1,800. Going to have 1,800. 1,800. Then we add the appropriate unit for work done, which is finished work. And that's exactly what we are expecting. Yes. So we have 150 times 12, we have 1,800 to slightly date. Yes. Now practice question 2. If you are given the work output 60 joules, work input 75 joules, and you have to find the efficiency, you simply substitute. So yes, so you know efficiency is work output. This is our work output. This is our work output 60 of our work input 75 divided by what? Multiply by 100%. So when you multiply and do that, you're expected to get an answer. Yes, so you see our work output is 60. So that's the 60 here. And our work input is what? 75. So that is our 75 here. Multiply by 100. And when you compute this, you are going to get 80%. Now, if you have to summarize all that we have done, you know, work is equal to force times distance. This is a formula. So have this in mind. Or you can use the definition. Work is said to be done when a force moves a body through a distance and in the direction of the force. So that will guide you to know the formula. Now, if you input a force, it is the effort you are going to use. And since you are moving through a distance, you're going to have the effort distance. Yes. Then work output is load times load distance. Then efficiency is the work output divided by the work input multiplied by 100%. Now, if you know this and you know that, you can easily find this. If you know efficiency, you know work output, you can easily find the work input. It is a matter of you doing your change of subjects, and if you do them well, you'll be able to get the answer right. So this is the end of the presentation. Thank you very much. Please make sure you watch, subscribe, um, and also comment. Stay tuned for the next video. Thanks for watching.